In your UniFi network, you may have a UniFi gateway. It acts as a router as well. You may have multiple layer 3 switches and of course some layer 2 switches as well. You may wonder in this type of network setup whether the layer 3 switch VLANs can work in every single switch. Doesn't matter whether it's layer 2 or layer 3. And you may also want to know how the routing works exactly, depending on whether the VLAN is managed by the gateway or by the layer 3 switch. So in this video, let's explore the details. I'm going to use this type of lab environment. I have a UX3 Pro, 2 layer 3 switches, Pro 24 and Enterprise PoE switch, and I have a non-layer 3 switch, a regular layer 2 switch, USW24. And in UniFi Network Controller, I have multiple VLANs set up already. The default network, VLAN 10, 20, 3 of them. They have the UX3 Pro as the router. Then I have VLAN 66, 88, and 99. They have the layer 3 switches as the routers. So 2 of them are using the Pro 24, 1 using the 8-part enterprise switch. Let's see in this environment how the routing works. In the lab, I will run multiple Linux virtual machines. They belong to different VLANs. To understand how the routing works, in each router or layer 2, layer 3 switch, let me SSH into them. Okay, I'm in. Let me show their IP addresses first, starting from the router itself. Okay, the 1 part, Ethernet 2, and the BR0 for default network, BR10, and the BR20. 3 of them, they are for the 3 VLANs managed by the gateway, right? Then the last one is BR4040. It is a special VLAN for the layer 3 switch inter-VLAN routing purpose. We will look into this in more details later. On the diagram, I also marked their important IP addresses for each network device. Then for the first layer 3 switch, let me do the same thing. Ethernet 0 is for the IP address for the switch itself. Then it has 3 virtual devices. The 4040 is for the layer 3 purpose to communicate with other layer 3 devices and the router. Then it has the virtual network device for the VLAN 66 and 88, both managed by this particular layer 3 switch. Then move on to the second layer 3 switch. Similarly, it has the VLAN 4040 and it has VLAN 99 for the VLAN managed by this particular switch. Okay, then move on to the layer 2 switch. This one should be very simple. Okay, it only has 1 IP address for the switch itself. So I marked the information on the diagram for the IP address. When we check the routing table for each of them, they will be using these IP addresses for the routing. So let me clear screen so that we can have a clearer view for the routing table. To show the routing table, there's one command you might be very familiar with, just simply route. Okay, but I prefer another command, which is IP route. It will show you more information. And for this particular video, I will use -D just to display more information. Okay, let me show all the main routing tables in the 3 switches as well. Okay, so let's look into the router, the gateway itself. I'm not going to go through all the routes one by one. I'm only going to mention the ones which are important to this video's topic. For this one, it is for the routing about 1 part. This lab environment is behind my main router. So that's why here for the gateway IP address, you see a private IP address. Okay, and these 2 are straightforward for the 2 VLANs managed by the router, VLAN 10 and VLAN 20, right? And let's look into these 3. They are for the VLANs which are managed either by this layer 3 switch or by this layer 3 switch. So these 3 VLANs, 66, 88, 99, they are not managed by the router itself. Even for the router to visit these 3 VLANs, it need to go through another router. Which router? Depending on which layer 3 switch manages the VLAN. For example, for VLAN 66, it is managed by this router, this L3 switch. So that's why it need to go via this IP address, which is the inter-VLAN routing for the layer 3 switch for this particular switch. So this is the IP address for this one. And in the similar way, for VLAN 99, this is the IP address for the other layer 3 switch. In this way, the gateway itself can route the traffic to the correct layer 3 switches. And then the other one, this one, is about this particular VLAN 4040's routing. So we will talk about in details later. Okay, so this is for the gateways routing table. For the first layer 3 switch, for VLAN 66 and 88, see, it will route by itself because this switch manage those two VLANs. But for VLAN 99, see, it is able to route VLAN 99 traffic as well, but it will go via the other layer 3 switch because itself, this switch, it doesn't have the VLAN 99 information. It has to rely on the other layer 3 switch. For all other VLANs or internet, it will do what? It will use this one, special VLAN 4040. You may notice here, interestingly, it has two default routes. You may know normally in routing table, you only have one default route, right? So later we will discuss this default route situation for this switch. Then move on to the second layer 3 switch. See, it has the similar situation. It has two default routes. We will talk about that later. Similarly, for VLAN 66 and 88, it need to go through the other layer 3 switch. And for VLAN 99, it can manage the traffic by itself. Okay, then about the layer 2 switch, of course, we don't expect it to do anything regarding routing because it is not layer 3 switch at all. Having talked about the overview, now let's look into the individual details. First thing, let's investigate. See this part, the protocol part. If I show you the IP route man page, let me search the protocol. See here, it has explanation about what protocol is, and it lists several typical ones: boot, kernel, static. These three are very common in Linux routing table, but the man page itself may confuse you about the explanation what these three means. Here is my understanding. If it's kernel, it means you configure the IP address and the network on the interfaces on the operating system level. If it's boot, it simply means it's the default origin, so it's not any of the other protocol. If it's static, it's very simple. It's not automatically generated, it's statically added by you or by the software. Okay, then if we go back to the routing tables, see, we see, for example, for the first layer 3 switch for VLAN 66, the protocol is kernel. Why? Because it's configured by the UniFi network controller, because VLAN 66 is maintained by this switch. And for example, for this one, for the switch itself, it has this default route. Where it's from? Because this switch has the UniFi gateway as the router. That's why the protocol is boot. But interestingly, for the first layer 3 switch, you can see this interesting protocol. It's called ICOS. If you try to search internet about what's IP route protocol ICOS, you may not find anything. Let's look into what's this ICOS for at all. You may know many modern Linux, including the UniFi switches and UniFi gateway, they use IP route 2 to manage route. So let me go to the IP route 2 folder. For this file, it defines the custom protocols. So let's display it. See, it's very simple. It has a ICOS and then it has a number. So this is the protocol number. That's it. That's the only information it has. But this SSH session is for the second layer 3 switch, right? If you look into the routing tables carefully, you may see for the similar default route as this one, in the second layer 3 switch, it's showing like this. So the protocol is simply static. So you may ask, ask why for the similar route for different layer 3 switches, they use different protocols. In the interest of time, I won't show you in the video, but I did check my another UniFi network environment. What I observe is if your layer 3 switch is a relatively older one. For example, for my case, this Pro 24, or you have the old enterprise switch, they will use the protocol ICOS. But if you have some relatively new switch, for example, in this case, it's the enterprise 8-port PoE switch, or you have the new Pro Max switch. If that's the case, you will see the protocol static. So my understanding is simply because of the different ubiquitous implementation. For older implementation, they use protocol ICOS, and for newer implementation, they simply choose static. That's my theory. If you know more information about the ICOS, please let me know. But in my current understanding, I simply treat the protocol ICOS as protocol static. It's simply a static route. So this is one information I want to highlight. The other one is more interesting. So see, for this two layer 3 switch, they both have two default route. Default route meaning during routing, if the system cannot find more proper dedicated routes, they will default the routing to the default route. But if you have two default routes, how the system even make the decision, right? Let's find it out. Let me do a very simple testing. From this VLAN 66 machine, let me ping this VLAN 10 machine. Keep in mind, VLAN 10 is managed by the gateway. VLAN 66 is managed by the first layer 3 switch. So the route will go from the layer 3 switch to the gateway. Find out their IP address first. Let me ping the VLAN 10 machine from the VLAN 66. Let me ping the VLAN 10 machine, only ping it once so that we can examine the traffic carefully. From the SSH session to the gateway, let me run TCP dump. What I'm saying is I want to monitor all interfaces only if the source IP address is this one. This IP address is the VLAN 66 client IP address. So in this way, I will see which route is used. Let me run the TCP dump in gateway first. Okay, it's running. Then from the VLAN 66 machine, let me ping VLAN 10. Okay, let's see what happened. From the VLAN 4040, it received a packet, and it is from this VLAN 66 machine to the VLAN 10 machine. Just from this packet, we already know which route is used in layer 3 switch. Let's go back to another screen. See this layer 3 switch routing table. Which one used the VLAN 4040? It's this default route. During runtime, when the VLAN 66 client wants to connect to VLAN 10, this default route is used instead of the other one. It answers the question which default route will be chosen if the layer 3 switch client needs to reach out to another VLAN managed by gateway, not by the switch itself. It will use this default route, the VLAN 4040. In fact, to better understand the two topics we just mentioned, the protocol ICOS and the two default routes situation, we can use CLI command in the two UniFi switches to get better answers. So let me go to the CLI for both switches. Okay, let me run the same command, show IP route. Okay, the CLI gives us better information than the operating system level routing table. So see here, it clearly says the default route is through this VLAN 4040 interface, right? The same information for both switch. And the route type is static. Remember, from the operating system level, we see the protocol is ICOS for the first switch and static for the second switch, right? But from CLI, they are the same thing. They are both static. They are both default route. Then let's go back. Based on the information we see here from the four routing tables, I draw this diagram. I will not go through all of them. Let's go to more interesting thing, which is let's use real world machines to connect to different devices to see how the routing works in action. First scenario is very straightforward. This first layer 3 switch manages two VLANs, right? So I connect two Linux machines to this switch. Similarly, for this enterprise switch, I connect VLAN 99 client because VLAN 99 is managed by this switch. Then for the layer 2 switch, I connect two clients. These two VLANs, 10 and 20, they are managed by the UniFi gateway. This scenario is guaranteed to work, right? So let's test it out. Let me do a trace route from VLAN 66 to VLAN 88. Okay, see, it's very simple. First, reach out to the layer 3 switch, and then it can reach out to VLAN 88 without going out of this switch itself. From this routing diagram, you can also see for VLAN 66, if it need to reach out to VLAN 88, it simply go with this route. Okay, from VLAN 88, let me trace route to VLAN 99. Okay, so this time it's more complicated. It need to first reach out to this layer 3 switch. That's the first hop. Then the second hop is to reach out to the VLAN 4040 IP address of the second layer 3 switch. And then it will reach out to the gateway for VLAN 99. 3 hops in total. If you check the diagram, what really happened was the client reach out to the first layer 3 switch, first hop, then reach out to the VLAN 4040 IP address for the second layer 3 switch, then reach out to the gateway for VLAN 99. So first hop, second hop, third hop. You can see the traffic is contained within the two layer 3 switches. It never goes to the gateway. Then let's see what will happen if from VLAN 10 we reach out to VLAN 66. Okay, 3 hops. So first, VLAN 10 reach out to the gateway, then gateway reach out to the IP address of the VLAN 4040 of the first layer 3 switch, and then reach out to the VLAN 66 client. So if you check the diagram, the VLAN 10 client reach out to the gateway, then the gateway reach out to the layer 3 switch by using VLAN 4040, then layer 3 switch reach out to the VLAN 66. Okay, then move on to second scenario. This time I moved several clients around. For example, I switched the position of VLAN 88 and VLAN 99. Remember, VLAN 99 is managed by this switch. VLAN 88 is managed by this switch, right? So in this way, we can test out whether I can have a client on a UniFi layer 3 switch, but the VLAN is not really managed by this switch. Instead, it's managed by another layer 3 switch. Let's see whether it works. Because we switched the position of these two clients, our testings will also be focusing on these two clients. So from VLAN 66, trace route to VLAN 88. See the same two simple hops. If we compare it with the diagram, you can see from the VLAN 66, it reach out to the first layer 3 switch, the first hop, because the first layer 3 switch also has the gateway for VLAN 88. It directly reach out to the VLAN 88 machines. So it doesn't matter whether we switch the two clients connection or not, the routing works in the same way. And we can try from, let's say, VLAN 20. Let me trace route to VLAN 99. See, again, the same 3 hops. From the VLAN 20 machine, it reach out to the gateway, then gateway reach out to the layer 3 switch IP address for the VLAN 4040. Then the second layer 3 switch, it manages VLAN 99. It can directly reach out to the VLAN 99 machine. It doesn't matter whether this machine is connected to this switch or not. The routing works in the same way. Okay, by the way, before I start testing the trace route for this scenario, I already physically switched the connection, even though I didn't show you. Okay, move on to the third scenario. So this time, let me connect the VLAN 10 and the VLAN 20 machine to the two layer 3 switch, and then connect the VLAN 66, 88, and 99 clients to the layer 2 switch. This is a very weird physical connection scenario, right? So let's see whether the routing works as expected or not. For all the 5 Linux machines, I already physically changed the connection to different switches, and I also refreshed the DHCP just in case. Okay, let's test whether the traceroute works in the same way. From VLAN 10, traceroute to the VLAN 20. Okay, in the same simple way. At first, reach out to the gateway, then directly reach out to VLAN 20. Then from VLAN 20, reach out to VLAN 66. Okay, again, the same way. First, reach out to gateway, then to the VLAN 4040 IP address of the first UniFi switch, and then it directly reach out to the VLAN 66. So the routing works in the same way, no matter how you physically connect the clients. So then let's test these 3 VLANs as well. So from VLAN 66, reach out to VLAN 88. Okay, in the same way, right? It hop to the first UniFi switch, layer 3 switch, then hop to itself. From VLAN 88, trace route to VLAN 99. Okay, first hop to the first layer 3 switch, then hop to the second layer 3 switch through VLAN 4040, then hop to itself because this switch manages VLAN 99, right? Okay, so after these 3 quick scenario testing, you may realize the routing works in the exact same way, no matter how you connect your clients to which switch. So if you simply check the routing, it works in the same way. But it doesn't mean your packet will go through the same physical links. So depending on where you connect to your client, you may either save some traffic, some network bandwidth, or you will waste some network bandwidth. But that's different story. If you purely talk about the routing, they work, and they work in the same way. If you talk about the bandwidth efficiency, yes, you may want to consider to connect client to the more proper switches. Another thing you may want to consider is the speed. Even though just from the routing perspective, the trace route returns the same results, it doesn't mean your network packet traverses the same switches. So let's use a very simple example to show the effect. In this third scenario, VLAN 88 and VLAN 99, they are connected to the same layer 2 switch, right? From VLAN 99, let me run a iPerf3 server. Okay, then from VLAN 88, let me test the speed to VLAN 99. Okay, you can see it's 1 gigabit, right? But if we change the physical connection for these 2 Linux clients from the diagram, just for clarity, let me remove these 3 clients which we are not using. Then I'm going to change the client to this way. Okay, so instead of connecting them to the layer 2 switch, I'm connecting to this one. Do you realize the difference? These 2 clients now have 2.5 gigabit physical link. Instead of in this way, they only have 1 gigabit physical link. So let's see what's the difference. The same client, the same routing, right? From VLAN 88, let me test the performance. See, now you have 2.5 gigabit speed. Okay, I just want to show you the routing and the physical speed and the physical bandwidth utilization are different things. When you connect your clients, you need to consider both. Okay, this and this video. Thanks for watching.